Righto, so in this video we're going to have a look at graphing absolute value functions. So an example of an absolute value function, the most simple one, is y equals the absolute value of x. Well, remember, we know what, let's think about what we know. We know that y equals x is just a line that goes through the origin with a gradient of 1. Okay, now it doesn't start at the origin, of course, we know that it goes up this way, but it also continues down back this way. But if y is the absolute value of x, that means when x is -1, well, y doesn't go down to -1 there. And when x is -2, y doesn't go down to -2, because y is the absolute value of whatever x was. So when x is -1, the absolute value of that is 1. When x is -2, the absolute value of that is 2. When x is -3, the absolute value of that is 3. So what happens is the line, instead of passing through and continuing down here, it's almost like it bounces off the x-axis, okay? Because the absolute value stops it from being negative, right? So it comes down, hits the x-axis, can't go below because the absolute value of x has to be a positive or 0. So it hits the x-axis, bounces and goes back up the other way. And it's really easy for us to know the equation of the line that's going up the other way. It's just the negative of this line. So this is y equals x. So this line here is going to be y equals -x. And that's the graph of the absolute value of y equals, let me try that again. That's the graph of y equals the absolute value of x. So, okay, how can we vary this guy? Well, we can really, in 3 different ways, or a few different ways. Let's go through those examples. I might have y equals the absolute value of x minus 1. Now, you'll remember from when we looked at graphing parabolas, we've seen something like this before. Right? When we had the graph of y equals x, so it was a parabola that touched at the origin. When we had y equals x minus 1 squared, that minus 1 shifted our parabola. Okay. Now remember the rule that I explained to you, that the negative makes it late, and if it was a plus, the plus would make it early. So y equals the absolute value of x would normally bounce off at the origin. Okay. So if this was y equals the absolute value of x, it would bounce off at the origin. The minus 1 makes that happen late, and so instead of bouncing at the origin, instead of bouncing at the origin, the minus 1 means that we're bouncing off here at 1. Okay, to make that a bit clearer. So there's our line, y equals x minus 1. Oops, sorry, having a bad day today. Y equals x minus 1. Okay. So again, the absolute value stops us from being negative. It bounces off and then turns us up to be positive. So if I was to continue y equals x minus 1, where would that cut the y-axis? Well, the y-intercept is given by the constant term over here. It would, if it was to continue going down here, it would have cut at -1. Okay, but we don't go down beneath the x-axis, we bounce off. So what happens is we bounce off, and instead of cutting down there at -1, instead we're cutting up here at 1. And the equation of this half of the line is going to be the negative of the equation here. So this is y equals x minus 1. This is going to be y equals -x plus 1. Okay, the negative of that side. And we've drawn our function. Okay. Now you need to be a little bit careful. If it's just a sketch, you don't need to be overly obsessive about any kind of scale, but you do need to kind of show that the gradient with which this half of our graph increases is the same as the gradient with which this half decreases. So don't have, for example, don't have this going up like that and that going out like that. You know, it's meant to be a much more, well, it's meant to be a perfectly symmetrical V. Okay, so don't go drawing your graphs like this. Make sure they maintain that symmetry. Okay, so we looked at making our graphs late. A +1 would just make the same graph early. It'll just shift it over and bounce off here at -1. So imagine if I just got the whole graph and slid it back here to -1. That's what we'd have if we had y equals the absolute value of x +1. So we see what x plus or minus a constant would do. We don't need to extend too much further to see what we'd have if we looked at, say, y equals the absolute value of 2x minus 3. Okay, so what happens there? Well, what I recommend, a really easy way to draw these, is to think about what it would take to draw y equals 2x minus 3. Well, y equals 2x minus 3 would cut the y-axis at -3. So it would have cut the y-axis down here at -3. It would have had a gradient of 2. So that means that it'd come up for every 1 unit it went across, it'd go up 2 units. That means that it'd go through the x-axis here at 1.5 or at 3 on 2. And it would continue up that way. Okay, but remember the absolute value means that we don't actually go beneath the x-axis. So instead we bounce off and we go up. We've got to maintain that symmetry in our sketch. So instead of cutting down here at -3, we cut up here at +3. The equation of this half of the line is y equals 2x minus 3, and on this half it's going to be the negative of that, y equals the negative of 2x plus 3. I'm not too good at writing on that angle, but I'm sure you guys will do better than me. That's not all. We can extend our drawing of these absolute value graphs a little bit further. So I'll do a part 2. Give me some time to clean the board. I'll do a part 2 to this video, and we'll see what happens when we look at things like y equals the absolute value of x plus or minus some constant. Okay, so that's coming up in the next video. Stay tuned.